We carry these incredible little devices around in our pockets every single day. They connect us to pretty much anyone, anywhere, almost instantly. And it really does feel like magic, doesn't it? But it's not magic. It's actually this amazing feat of science and engineering.
So have you ever really stopped to think about it? The moment you speak into your phone, what is that incredible journey your voice takes to get to the person on the other end? I mean, they could be halfway across the world and they hear you in less than a second. That's exactly what we're going to break down right now.
All right, so the whole journey kicks off the second you start to talk. The very first step is to translate the physical sound of your voice into a language that the phone and the entire global network can actually understand. So when you talk, what you're really doing is creating these vibrations in the air, right? Sound waves? The microphone inside your phone is designed to pick up those exact vibrations and turn them into a continuous electrical signal. We call that an analog wave, and it's basically a perfect electronic mirror of the tone and volume of your voice. But here's the thing about an analog signal, it's kind of messy. It can easily get distorted by noise and interference. To send your voice reliably over long distances, the network needs something much cleaner, much more precise, a digital signal. And that's just a stream of ones and zeros. So the phone's first big job is to turn that smooth, wavy analog signal into a clean, crisp digital code. So how does it do that? Well, there's this tiny little chip inside called an analog to digital converter, and it works in two really clever steps. First, it samples the wave, which just means it measures its height thousands and thousands of times every second. Then it quantizes those measurements, which is a fancy way of saying it rounds each one to the nearest value on a set scale. What you're left with is a super precise, number-based version of your voice. Now, this whole process, it creates a ton of data, way too much to send efficiently. So your phone, which is basically a powerful little pocket computer, uses these smart algorithms to compress all that information. You can think of it like zipping a file on your computer. It makes the message way smaller and a whole lot faster to send across the network. Okay, so now we've got your voice all neatly packaged up into a compressed packet of ones and zeros. The next big challenge is, how do we get it out of your phone and into the network? This is where the mobile part of mobile phone really gets to shine. Yeah, you might not think of it this way, but at its heart, your phone is basically just a really, really smart two-way radio. It takes those digital packets and piggybacks them onto a radio wave, which it then beams out through its antenna. And the very first stop on that journey is the closest cellular base station, what we all just call a cell tower. Now, that's all fine and dandy if you're just standing still, but what happens when you're in a car, zooming down the highway? You're moving away from one tower and getting closer to another one really fast. How does your call not just, drop? This is honestly one of the most brilliant parts of the whole system, the handoff. It's exactly like a relay race. As your phone's signal to the first tower starts to get weaker, the network is already prepping the next tower on your route to take over. It seamlessly passes your call, the baton, from one to the next. It happens so fast and so smoothly, you never even notice it's happening. But, sending a signal through the air, it's not a perfect science. You've got buildings, weather, all sorts of interference that can mess with it. So, what's the secret ingredient that holds it all together and makes it reliable? It's math. Seriously, a whole lot of very clever math. The system has this incredibly clever way of dealing with mistakes. See, bits of data can get lost or flipped along the way. So to fix this, your phone adds extra, redundant information into the signal. It's called error correction. Just look at this example here. Even if some pieces of the puzzle go missing during transmission, that extra information allows the phone on the other end to perfectly rebuild the original message. It's amazing. And then, of course, there's the big one, privacy. Before any of your data gets sent out, it's encrypted. That means it's all scrambled up using a super complex mathematical key. Only the person you're calling, their device, has the matching key to unscramble it. This makes sure that even if someone could intercept the signal, all they'd get is a bunch of scrambled nonsense. Now, this whole amazing system, the towers, the math, the handoffs, it didn't just appear overnight. It has been evolving like crazy over the last few decades, and each new generation has unlocked some incredible new things we can do. I mean, think back. 2G was the first big jump, giving us clear digital calls and, texting. Then 3G came along, and suddenly we had the internet in our pockets, which was a game changer. 4G made everything fast enough for HD video streaming on the go. And now, 5G is opening the door to a whole new world of connected cars and augmented reality because it has such huge capacity and almost zero lag. Each step has been a massive leap forward. So let's just do a super quick flyby of that whole journey again. Your voice gets turned into a digital signal. That signal is compressed, encrypted, and then shot out as a radio wave. The network of towers hands it off and routes it to the right person, and on the other end, that whole process just happens in reverse. All of it, in a blink of an eye. So when you really stop and think about it, that thing you're holding in your hand, it is so much more than just a phone. It is the end result of decades of research in physics, unbelievably complex math, and engineering on a global scale, all working together perfectly to create one of the most advanced pieces of technology humanity has ever built. At the end of the day, this device was built to connect people. That was its mission. But now, as we're moving into the age of 5G and whatever comes after, you have to wonder, right? What's next? What will it connect next? Our cars? Our entire cities? The possibilities? Well, they're pretty amazing to think about.